Hello everyone. I have updated the course website, and you can take a look at the quiz results. I have updated the quiz results of the previous week, and you can take a look to see whether your scores are correct. And I also update the results of assignment 1. And assignment 2 is announced, and the due date is November 22. And later I will explain explain assignment 2. And our midterm exam is on November 15. So if you take a look at the schedule, the midterm exam is on November 15. And the time is from 9:10 at this classroom. And the exam is paper and pencil, and the closed book. You cannot bring your own materials, and the calculators are not allowed. The exam scope cover materials between the lectures between the 2 days. And we will continue the slides. And in the previous week, we have learned how to use arrays. And we will finish the first part. And after finish the first part, we will go to the next chapter about functions. And after we learn functions, then we will return to the remaining parts, because the remaining parts requires you to know the concepts about functions. And we have learned how to declare an array. For example, if we want to declare an array, we can use the syntax like this line. And in this line, we declare array. The variable name is score. And after the variable name is a bracket. And inside the bracket is a number. This number specifies how many elements are there in the array. And each element is of data type double. And for this example, the index for score are from 0, 1 up to 11. So the reasonable range of the index are from 0, 1 up to 11. And index 12 is out of range, because index 12 means the 13th element. So you cannot. So it is a mistake to write your program like this line. This is a common mistake. And this line will not cause syntax error. This time is legal, but this time will cause runtime error. And you can try to write a simple program to test this to test how to use the array. And for this example, for example, I declare an array, and this array has 3 elements. But so the index, the range of the index should be 0, 1, 2, and the 3 is outside the range of the index. So this line is a mistake. But the compiler allows you to write in this way, so the compiler will not issue error message. But when you run this, when you run your program, when you run your executable, then you will encounter a runtime error. So the runtime error message is stack smashing detected, because we cannot assign a value to a memory address outside we have declared. So this example will cause a runtime error, but the syntax is legal. And this is the major pitfall for using array. And because the compiler will show no warning, so it is hard to detect such error. And this type of error will cause serious results. For example, your program will cause the operating system to terminate it. So this type of runtime error will cause disastrous results, and therefore programmers are responsible for checking the index range. We need to make sure that the index range is within the reasonable range. And next, these slides show how to use name constants to declare an array. For example, if we want to declare an array, and the array size is specified by this variable, number students. And number students is a named constant. And we have learned named constants. A named constant means it is a constant variable. Here, the number students is a variable, and its data type is integer. And we assign 5 as its initial value. And we also add a const modifier before the data type integer. So this modifier will make number students named constant. And this means we cannot modify the value of this variable. We cannot modify the value of number students. If we try to modify the value of number students, the compiler will issue error message. So if we add a const modifier before the data type, then the variable will become a named constant. And we can use this variable like a constant because its value is not changed. And the advantage of using named constant is that we can give a name to a constant. So we can, for example, the number of students is 5. We can give 5 a name. And in this way, it is better to understand your program. So using name constant will make your program more readable. And it is we often use named constants when we want to declare arrays, because we often need to access the number of elements in an array. So the named constants are often used when we want to declare an array. And using named constant improves readability, also maintainability. Maintainability means if we want to change the size of the array, you only need to change one line. Because there are many places you need to use the size of the array, and when you want to change your program, when you want to change the size of the array, you may need to modify many lines. But if you use named constant, you only need to change one line. You only need to change the definition of number students. And below is an example to use the name constants. And for example, we want to access the elements in the array, then we can use a for loop. And the index begins from 0. And in each iteration, the index is increased by 1. And the Boolean expression is the index is less than the size of the array. And here the size of the array is number students. And we can also compute the index of the last element. The index of the last element is number students minus 1. This slide introduces another way to write a for loop. But I will skip this slide because due to the time insufficiency. And next, let's see how arrays are allocated in memory. for simple variables, when we declare a variable, this means we allocate memory for that. We allocate memory to store values. And this is when we declare arrays. We also allocate memory for the entire array. And the memory are allocated sequentially. This means the memory addresses are allocated back to back. Later we will see an example. And we can use this property to calculate the memory address of each element in the array. For this example, I declare an array A, and this array has 6 elements. Each element has data type integer. And we suppose for this example, we suppose each integer has 2 bytes. For this example, we suppose integer has 2 bytes. And for other examples, the size of the integer might be different. And suppose the memory address of the first element is 1023. And we know that each element is an integer. So each element will occupy 2 bytes. So the first element will occupy 2 bytes, 1023 and 1024. Here, one unit means 1 byte. So here, the unit is 1 byte. And we can calculate the memory address of the fourth element, A3. A3 is the fourth element. We can calculate the memory address of the fourth element. And we know that A3 and A0, the distance between A3 and A0 are 3 integers. And 3 integers in this example, 3 integers means 6 bytes, because in this example, each integer is 2 bytes. So 3 integer means 6 bytes. And therefore, the memory address begins from 1029. 1029 is we add 6 to 1023 because the distance between A3 and A0 is 3 integers, and the 3 integers corresponds to 6 bytes, and therefore the memory address of A3 is 1029. And we can also use an example to print the memory address of elements in an array. And for example, For example, we can print the memory address of the first element of the array. And to do this, we add the AND symbol. The AND symbol is an operator. This operator can allows you to get the memory address of the memory variable behind the AND operator. So to print the memory address of the first element, we use the AND operator. And we can also print the memory address of the second element. And we can see the result. Let's bring it. And I also print the size of integer. And we can use the size of operator to print the memory size of a data type. And for this example, the size of integer is 4. And this means the integer data type occupies 4 bytes. And so the first element and the distance between the first element and the second element is 1 byte. And 1 byte means 4 bytes for this example. And we print the memory address in the second line and in the third line. And so the memory address of the first element is this number. And this number is not decimal because you know that this number begins from 0x. And if you see a number begins from 0x, this means this number is in hexadecimal. So when you see a number begins from 0x, then this means this number is in hexadecimal. And each number can is range from 0 to 15. Oh. Okay. You mean this line or? Oh, this line is to print the memory size of an integer. Four bytes in this example, one integer is 4 bytes. It's 4 bytes. One integer. This is a data type of integer. This line is independent of this line. Yes, this line is independent of is independent of the declaration of the array. You mean? Oh, you want to know the entire size of the array. You can change this to score. For example, we can. it's 20 because if we want to know the size, the memory size of the array, then we can use size of and the array's name. And because each integer is 4 bytes, and because each integer has 4 bytes, and the score, the array has 5 elements. So 4 times 5 is 20. So the memory size of the score array is 20. And we can print the memory address of the first element. And this number is in hexadecimal. We know that each number is ranges from 0 to 15. And if the number is 10, and it will be denoted by A. If the number is 11, it will be denoted by B. So if the number is 15, the number will be denoted by F. So this is the memory address of the first element in hexadecimal format. And we can also print the memory address of the second element. And you will know that the difference between the two memory address is 4, because the distance between the first and the second elements is 1 integer, and in this example 1 integer has 4 bytes. So the difference between the memory address of the first and the second elements is 4. And you can also change the data type. For example, you can change the data type to double. And we know that the size of a double is 8. The memory size of one double variable is 8. And the memory size of the array changed because A times 5 is 40. Because each element in the array occupies 8 bytes, and the A times 5 is 40. And we can also see that the distance between the address of the first and the second element, and you see that the difference between the two memory address is 8, because the memory size of one double is 8. And you can use this example to understand the memory allocation for an array. And let's return return to the example in this slide. There is no index variable A6, but because 6 is outside the range, the range is from 0 to the range of the index is from 0 to up to 5. So A6 is outside the range of the array. But if we want to use this notation, if we want to use A6, then the location of A6 is here, shown by this arrow. The memory address of A6 is 1035, because the memory address of A6 is 1023 plus 6 integers, and 6 integer means 12 bytes. So 1023 plus 12 is 1035. So if we want to access A6, then we are accessing the memory this memory address 1035. But this will cause runtime error, because if your index is outside the array, if you assign some value to the memory location outside the array, this will cause a runtime error. For example, if you want to assign for example, I try to assign one value to this memory location, and this will cause a runtime error, stack smashing detected, because the index 5 is outside the range. And in this slide, I will summarize how to initialize an array. The first way is the standard one. If we want to initialize an array, and we add this is just like we initialize a variable. And on the right hand side of the equality, on the right hand side of the assignment operator, we use the brace. We use braces, and inside the braces are the elements of the array. And because this array has 5 elements, so inside the braces are 5 integers. This is the first way, the standard way to initialize an array. And the second way to initialize an array, we can omit the number inside the bracket, because on the right hand side we already give the initial values of an array. So the compiler can automatically determine the size of the array. Because because this assignment assigns 5 numbers to an array, so the compiler can automatically determine the array size. We can also use the second way to declare to initialize an array. And next, the third way is the third line. Introduce another way to initialize an array. For example, suppose we want the initial values to be 1, 2, 0, 0, and 0. And then we can omit the last 3 zeros. We can omit the last 3 zeros. So for this example, on the right hand side, we only need to write 1, 2. And the compiler will automatically assign 3 zeros to the remaining elements of the array. And if we want all elements of the array to be 0, then you can write, on the right hand side, you can write 0, 0, 0, 0, 0. You can also write 1, 0. Because the compiler will automatically generate zeros for the remaining elements you do not give initial values. So this line will initialize all elements to have value 0. And you can also omit 0. So you can also write in this way. And for this line, inside the braces is empty. There is no numbers inside the braces. And this is valid. This is valid C++ syntax. But this syntax is invalid in C. So if your compiler is a C compiler, then you cannot initialize your array in this way, because the syntax is invalid in C programming language. But this syntax is valid C++. And let's see if we omit the assignment, then what will happen? If we omit the assignment, then what will happen? And this line just declare an array of 5 elements, but we do not initialize the array, because we do not use the assignment operator. And in this example, the 5 elements will be initialized to 5 unknown integers. And for beginners, often if beginners declare an array in this way, they often assume the integers have value 0, but this is wrong. This is wrong. If you do not initialize an array, then the initial values of the array elements are unknown. And you can try to print the values stored in the elements of an array. And for example, you know that I declare an array. This array has 5 elements, and you know that I did not initialize this array, and I try to print the values in the array, and we see that the values are random numbers. The values are random numbers. So you cannot assume the initial values of array are zeros. But if we initialize the array by the assignment operator, then let's see the output of this program. And you see that if we add the assignment operator, then this means we want to initialize this array. And if we don't specify numbers, then the compilers will initialize the values of the elements to be 0. And let's take a break for 10 minutes. Hello everyone, let's continue our class. And I use one example to show how to initialize an array. For example, if we want to specify the initial values of the array, we can use this syntax. And in this example, this array has 5 elements. So on the right-hand side of the assignment operator, there are 5 elements. But if I omit some elements, then the compiler will automatically assign zeros as the initial value of the array elements. And if inside the braces is empty, then the initial values of the entire array are zeros. But if we omit the assignment operator, then the initial values are random numbers. So the initial values are unknown if we do not initialize an array. And we can let's see the last example. And this example shows how to compute the array size. We can use the size of operator. And you can try to copy this line into the IDE. For example, I use this expression to compute the array size. And the numerator is size of score. And this returns the memory size of the array. And this array has 40 bytes because because one double has 8 bytes, and this array has 5 elements, so 5 times 8 is 40. So size of score is 40, and each element here I use the first element. I compute the memory size of the first element, and this number is 8 because each element is of data type double, and the one double is 8 bytes. So size of the first element is 8. And you can also print the value of each size of For example, we can print the memory size of the score, which is 40. And we can also print the memory size of each element. And because each element is a double, and one double has 8 bytes, so the memory size of the first element is 8. And if we divide 40 by 8, then we get the array size. So the array size is 5, which is the same, which is consistent with this declaration. And we have finished the first part, and then we will go to the next chapter about functions. And after we learn functions, then we will return to the remaining parts about arrays. And because the remaining parts requires you to know the notions about functions. And next we will have a quiz. And raise your hand if you need papers. The first question asks you the value of sum after the above statements, after the 4 statements. And you have 3 minutes to finish this question. And 30 seconds left. And I will close this question. And I open the second question. And 2 minutes left. And I will close this question. 3 minutes left. Uh, 30 seconds left. And I will close this question. I will collect the papers, and if you remember to write down your student ID and your name. And I will, okay. It seems that the Ruvio server has some problem, so many of you cannot, might not be able to use the Ruvio. And let's see the first Nobody answers. And maybe later some, if you use the Rubio, your answers might later will be upload to this page. And for this question, the correct answer, the correct answer is 38. And the initial value of sum is 10, and the index n begins from 1, and in each iteration the index n is increased by 4 until it is larger than 15. So and inside the body statement, sum will be added by n. So in each iteration, sum is added by n, and therefore in first iteration the sum is added by 1. In the second iteration, sum is added by 5, and this iteration continues until n is 13. If n is 16, then n is outside the Boolean expression. So sum, the value of sum is 10 plus 1 plus 5 plus 9 plus 13. And therefore the answer is 38. The answer is 38. And let's see the second question. This question requires you to compute the value of sum after the above statements, and the correct answer is 4, unknown. And because we do not initialize sum. For this example, we only declare sum, but we do not initialize. So we do not give initial value to variable sum, and therefore the value of sum is unknown. It is a random number, and after some computations, the value of sum is still unknown. So the correct answer is unknown. And let's see the third question. The correct answer is 20. And let's see how to compute the value of sum. And we know that this for loop has 10 iterations, because n begins from 1, and the Boolean expression is n is less than or equal to 10. So this for loop has 10 iterations, and in each iteration the value of sum is increased by 1. And we also know that the initial value of sum is 0. And in each iteration, the value of sum is increased by 1. So the value of sum is at least 10. And next, let's see, there is one if statement. If n is greater than or equal to 5, then the continue statement will be executed. And after the if statement is another statement, sum plus equal to n. And this statement will not be executed if n is greater than or equal to 5 because of the continue. So n is greater than or because of the continue statement, sum plus equal to n will not be executed if n is greater than or equal to 5. So we can compute the value of sum. And in the initial value of sum is 0. And in each iteration, the value of sum is increased by 1. So the value of sum is at least 10. Then sum is plus equal to n. And the n is from 1, 2, 3, 4. So the correct answer is 20. Because if n is greater than or equal to 5, then due to the continue statement, sum plus equal to n will not be executed. Any problem? Continue only break. This is continue, not break. If this is break, then if n is greater than or equal to 5, the for loop terminates. But this is continue. So this line will always be executed because this is continue. And let's see, for example, for the first iteration, when n equals 1, sum is added by 1, and then we enter this statement. We check whether n is greater than or equal to 5. But this is not true because n is 1, so we will not execute continue. So n will be is plus equal to 1. This is the first iteration. Then this will continues until n is 5. When n is 5, we will still carry out this statement. N is added by 1. And when n is 5, then the Boolean expression inside if is true, then we will execute continue. And when we execute continue, this line will be skipped. And then continue means we continue the loop. So n will increase by 1, and the value of n is 6. When n is 6, it is still less than 10, so we will go to this line. Sum is added by 1. And again, we check the if statement. When n is 6, it is greater than or greater than 5. So we will execute continue. And this line will skipped. And since it is continue, we will continue the for loop. So this line will be executed only when n is 1, 2, 3, 4. And this line will be executed when n is from 1 up to 10. You can try to change continue with break. The result will be different. Because if you change to continue with break, then when n equals 5, the for loop terminates. And the result will be different. And if no questions, we will return to our slides. And we have finished the first part, introduction to array. Then we will go to the next chapter, functions, function basics. And before we go to function basics, I will explain assignment 2. Assignment 2 is announced, and the due date is 3 weeks later. And I will explain assignment 2. And this program is to write, this assignment is to write a program to display a calendar based on user inputs. And the user will input 2 numbers. The first number is the number of days to be displayed. And I assume the first number is between 21 and 31. And the second number is the day of the week corresponding to the beginning of the month. And the range of the second number is between 1 and 7. And let's see one example. For example, the user input the first number is 30. And the 30 is the number of days to be displayed. And then the user enter the second number. And this number is ranges between 1 and 7. If the number is 1, then this means Sunday is the first day of this month. If this number is 2, then this means Monday is the first day of this month. And for this example, the second number is 3, and this means Tuesday is the first day of the month. So the calendar is like this. The first column corresponds to Sunday, and the second column corresponds to Monday, and the third column corresponds to Tuesday. And because the first day of this month is Tuesday, so the correct position of 1 is here. And after 1, you need to add a comma after the number, and after the comma, you need to insert spaces. if the number is a 2-digit number, then you just input one space. But if the number is 1 digit, then you need to input you need to output 2 spaces because we need to align. We need to align the output. So if the number after the comma is 2 digit, we only output 1 space. But if the number of after the comma is 1 digit, then we need to output 2 spaces for alignment. And you need to determine when to insert line break. You need to determine when to insert line break. And for this example, after 5, we need to output line break because 5 is Saturday. And after Saturday, we need to output a line break. And after 5 is 6. 6 is Monday. Then you follow this rule to print the calendar. And the same as assignment 1, your program should be exactly the same as those in the input-output samples. I give more input-output samples in this file, and you can check whether your program outputs are correct. Your program outputs should be identical to the examples in this file. And I also give a code template, and you can modify the code template to finish this assignment. Below are some suggestions. You can give meaningful names to variable 1 and variable 2, and below are some explanations. This assignment is to practice the use of for loops and if statements. You can use for loops to print the initial spaces at the beginning of the calendar. For example, you can use a for loop to print the spaces, and you need to calculate how many spaces to be printed based on the user input. So first, you can use a for loop to print spaces at the beginning of the calendar. And you can also use another for loop to generate numbers of the calendar. You can use a for loop to generate 1, 2, 3 up to 30. You can use a for loop to generate these numbers. And inside the for loop, you can use if statements to determine when to print spaces, numbers, commas, and line breaks. We know that the calendar only contains 4 types of characters: spaces, numbers, commas, and line breaks. The calendar only contains these 4 types of characters. And the space is half width, not full width. Full width is only for Chinese or Asian characters, and the space is in English, so the space is half width forms. You cannot use full width forms space, and you cannot use \t to replace spaces. You can only use half width space. And after you display the whole calendar, after you print this calendar, you can add a line break after this calendar. But this line break is not mandatory, so you can also you can choose whether you want to add a line break or not after printing the whole calendar. And below I show some examples which do not meet the requirements specified by assignment 2. The first example is wrong output format. You can check this the output. The output seems correct because it outputs 30 days, and the first day of the week is Tuesday. The output seems correct, but the output format is wrong because there is one additional comma at the end each line of the calendar. So you know that after at the end of each line there is no comma. The comma is only between the numbers, but the comma is not at the end of each line. So for example 1, the output format is wrong because one additional comma is at the end of each line. And if your program output is like this one, the accuracy will be 0 because your program output does not conform the format. And let's see the second example. The second example is also wrong output format. At the first sight, it is difficult to know why this example is wrong. Because there is one additional space at the beginning of each line here before 13. There should be no spaces. You see the output of this example. Before 13, there is no space. But the example 2, for example 2, there is one space before 13. So example 2 is wrong output format because example 2 does not conform the output format. So example 2 is also in wrong output format because there is one additional space before at the beginning of each line of the calendar. And let's see another example. Example 3 is also in wrong output format because after the comma, if the number is 2 digits, then there is only one space. like this one. After comma, if the number is 2-digit, then there is only one space. But example 3, in example 3, after comma, there are 2 spaces. So the output format of example 3 is also wrong. And you should pay attention that your program output is like this one. If your program output is like example 1, example 2, or example 3, and the accuracy of your program will be 0 because your program output does not conform the output format. And let's take a break for 10 minutes. Hello everyone, and let's continue our class. And this chapter has 3 parts. And the first part is about predefined functions. The second part is about programmer-defined functions. And the third part is about scope rules. Scope means the range we can access variables. And first, functions are building blocks of programs, and other terminology will be used like procedures, subprograms, or methods. And C++ we use functions. And a function can be usually a function consists of 3 parts: input and the body. The body is is the process part, and the output. So we can think a function as IPO, input, process, and output. And a function is one basic subpart to any program. Because when we write program, we will use many predefined functions, or we will write functions by ourselves. So functions are building blocks of programs. First, I will introduce predefined functions. Predefined functions means functions are defined in libraries, and libraries is like IO string. For example, we use cin, or we use cout to print the values of variables, and the cout is a variable defined in the IO string library. And there are other libraries like cmath or cstdlib. Std means standard library. And if the library is in C programming language, then we will prefix letter C. So if you see a library name begins from C, and then this means this library is also in the C programming language. So in the C programming language, there is one library called math.h, and also another library called stdlib.h in C programming language. And if we want to use a predefined function from a library, then first we need to include. We use this keyword to include a library. And there are 2 types of predefined functions. The first type is those that return a value. And the second type is those that do not return a value. And if a function does not return a value, then we will call this function is a void. This function is a void function. if this function does not return a value. Let's see one example. For example, we want to calculate the square root of 9.0. Then we can call this function sqrt. And this function is defined in the CMath library. So here is an example to use the square root function. And this function is defined in CMath. So we need to include this library first. And inside the parentheses is the input of this function. And the output of this function is the value yielded by the function call. So the output of the function is the value yielded by this function call. Then we assign the output of this function call to another variable, the root. And I print the value of the variable. So the output of square root is 3. And we know that we call this expression as a function call. And the function call will yield a value. And the value is the output of the function. And we can also we can also use the return value of the function to do some arithmetic operations. For example, we can divide it by 10 or multiply some numbers. So for this example, we can perform some arithmetic operation. And this slide is about the absolute value function. And if the data type of the input is integer, you need to call ABS. But if the data type of the input is long integer, you need to call LABS. L stands for long. And if the input the data type of the input is float, then we need to call FABS. Here, the F stands for float. And this is very inconvenient because you need to call different functions for different input data types, although they do the same operation. They all compute the absolute value. And you don't need to memorize these functions. You don't need to memorize these functions. You just need to know if you want to use ABS, then you can look the manual. And there are other math functions like POW. POW means power, and this function has two inputs, X and Y, and the output of the power function returns X raised to the power Y. So if we want to compute 3 raised to power 2, then we can call this function. And you see that the result is 9 because 3 raised to power 2 is 9. And you can also change this number. This number need not to be an integer. It can also be a fraction. For example, for this example, if x is 9 and x raised to power 0.5, the result is 3. And next is another function. Here, this is seeding. And suppose the input is x, then this function returns the smallest integral value not less than x. For example, if the input is 2.3, then the output of seeding is 3. Because 3 is the smallest integral value, not less than 2.3. So this is the seeding function. And there is also another function called floor. And suppose x is the input. And this function outputs the largest integral value, not both are okay. You can use integer or integral. This is from the slides from the textbook. Integration. Integer value, or I can check because this is not written by me. This is from the textbook. The slides are from the textbook. Okay. And floor, this function returns the largest integral value or integer value, not greater than x. For example, if the input is 2.3, then the output is 2. Because 2 is the largest integer, not greater than 2.3. There are more math functions. For example, if we want to round a floating point number, you can call round, and then you can search the library. You can search the if you search the CMath library, then you can see all the functions in this library. We have introduced the power, the square, and the ceiling, the floor functions. And there are also other functions like round. You can round to the nearest integer. If a function does not return values, then this function is called a void function. But void function can still have inputs. Inputs sometimes called arguments. And when a function does not return a value, then this means this function does not send answers. For example, this function x1. This function has one input, integer value 1, but this function does not have outputs. So this function has no return value. So we will not assign not assign the output of this function to some variable. And so x1 is a void function, and this function is in cstdlib. And when we code this function, then this function will terminate the program immediately. And the number means the program will, when the program ends, it will send an integer to the operating system. If this number is 0, then this means the program terminates normally. But if this number is not 0, this often means the program terminates abnormally. For example, if we want to allocate memory to some array, but the operating system does not have sufficient memories, then we need to terminate the program. Then we can use exit. Or when we try to open some file, but the file does not exist, and in this case we might need to call exit to terminate the program. You can, for example, the program will print end normally. But if I add the function call exit 1, then this line will not be executed because the program terminates at this line. So after exit 1, this line will not be executed. So the output, the print does not print. So the console does not print end normally. And next, let's see another function in the standard lib library. And this function is called Rend. Rend can be used to generate random numbers. For some situations, for example, you want to perform some simulations, or you want to write a game, then you might need to generate some random numbers, and we can call Rend to generate a random number. And this function has no inputs, and this function will output a value between 0 and rand max. And here, rand max is a named constant. It is defined in the CSTD lib. And you can search this library. This rand max is a constant defined in the CSTD library, and this value is library dependent. It's library dependent, and it is the maximum value returned by Rend. And I print a random number generated by this function call. And you see that this is the random number. And this number will be between 0 and the rand max. And for this library, rand max is defined as this large number. But for some scenarios, we might want the random number is between 0 and 1.0. So we can do some mathematical operations so that the value of the expression will be between 0 and 1.0. the result is 0 because the data type is integer. I should change the data type to double. And you can run this program several times. You will observe that the random number will be different. For example, I run again. Oh, I need to change the seed. We observe that the random number is between 0 and 1 because we perform this operation. And the numerator is rand max minus rand. So the range of the numerator is between rand max and 0. The range of the numerator is between 0 and rand max. And the denominator is rand max. So if we perform this division, then the result will be between 0 and 1. And here we need to perform a cast. We need to change the data type of random max because the data type of rand max is integer. And the numerator is also an integer. And therefore, the division will be integer division. However, we want the result be a floating point number. So we need to change the data type of either the numerator or the denominator. And here we change the data type of the denominator to double. If we omit this cast, for example, if I omit this cast, then the result will be 0 because this is integer division. And if you look closely, you can change the numerator and get the same result. This expression is from the textbook, but this is not the only answer. For example, you can change this one to rand only, and the output is still between 0 and 1. So the expression to generate random numbers between 0 and 1 is not unique. There are many ways to generate random numbers between 0 and 1. And here the cast is to force floating point division. If you do not add a cast, then integer division will be performed. The second example is to do scaling. For example, I want to return random values between 0 and 5. Then we can use the modular operator. For example, Rend modular 6. Then the value yielded by this expression will be between 0 and 5. And we can also do shifting. For example, if we want the output value is between 1 and 6, then we can add 1. We can add 1 to the above expression. So if we add 1 to the above expression, then the value yielded by this expression will be between 1 and 6. You can run this program, and the value yielded by this expression will be between 1 and 6. Next is another function related to the Rend function. This function is called random number seed, and here this function begins with S, and S means seed, the seed of the random function. And let's see one example how to use Rend. And for this example, I write a function. This function is programmer defined. I write a function show 10 Rend, and the purpose of this function is to display 10 random numbers. So inside the function, I write a for loop. And this for loop has 10 iterations. In each iteration, it will print a random number between 1 and 10. And you can copy this function to the IDE. This function is a void function because this function does not return a value. So this function is a void function. And inside the function, I call this function. And let's see the output. And the console outputs 10 random numbers because of the for loop. The console output 10 random numbers, and the random numbers is between 1 and 10 because I modular 10 and then plus 1. So the random number, the expression, the value yielded by this expression is between 1 and 10. And you can generate more random numbers. And in this example, I generate 20 random numbers. And you can see that the range of the random number is between 1 and 10. 1 is the smallest number, and 10 is the largest number. You can also change it. For example, you can change this to 5. And when I can call this function repeatedly, for example, I can make a second function call. And the second function call will print another 10 random numbers. The first function call display 10 random numbers, and the second function call display another 10 random numbers. And we know that the random numbers are the sequence of the two function call. The output sequence of the two function calls are different. But in some case, we want the output sequence of the function call to be the same. If we want the output sequence of the two functions to be the same, then we can use Rend. And for this example, I call Rend before the shorten Rend. I embedded a seed 6 before shorten Rend, before the first shorten Rend, and the output sequence is this one. Then I change. Then I also embedded another seed, and the seed is also 6. So the seed for the two shorten Rend function calls are the same, and therefore the output sequence are the same. If you change the seed to a different number, and we know that the output sequence is different. And if you omit this one, the output sequence of the two function calls are different, because for the second function call, the seed is not this one. It's not Rend 6. So if we want the shorten Rend to output the same sequence of numbers, then we need to embed it the same seed for generating random numbers. And this number is, you can change this number to any integer. As long as the value of the seeds are the same, then the output sequence of the two function calls will be the same. For this example, the first function call and the second function call output different sequence of numbers. But if we use Rend to embed a seed, then this function, this shorten Rend and the last shorten Rend will have the same seed, and the two function calls will output the same sequence of numbers. sometimes we can use time. We can use the function called time to generate integer value for sRend. You can use this function and function time, and this function is defined in the time library. And next, we will go to the second part. The second part is about programmer-defined functions. And this part is to introduce how to write your own functions, just like this one. This one is programmer-defined functions. And later I will show how to define a function by yourself. And the advantages of programmer-defined functions are reuse, readability, and divide and conquer. We can reuse this function. For example, I reuse the function twice. If you don't use functions, you need to copy and paste twice. For example, if I want to display 10 random numbers twice, then I need to copy and paste the for loop twice. And this is inconvenient because you need to copy and paste many times. But if we use function, if we use programmer-defined functions, we only need to make 2 function calls. So one advantage of function is to reuse. And the second advantage is readability, because it is clear that we do two shorthand Rend, because we call shorthand Rend twice. But if you do not use functions, you need to copy and paste the for loop. And you note the readability. The readability of this code is very the readability is not good, because you need to check every line. You need to check whether the second loop is the same as the first loop. So the readability of this style is bad. And using function is a better style. Using functions is a better style to write programs, because functions can be reused, and functions also improves readability. And the third advantage is to divide and conquer. If the solution to your problem is very large, you can divide your solutions into many subparts. and then write functions to solve the subparts and then combine the results. This is the divide and conquer approach. And you can place the definition of the programmer-defined function in the same file. In the same file as main, or you can place the definition of the program in another file. For example, you can put the definition of this function in another file, but you need to include that file if you need to call this function. And the time is up, and let's end here.